In this video, we're building a SwiftUI app that allows us to fetch food data based on plain text. As output, we'll be getting a list of foods in the order in which we wrote them down, and at the end, we'll get an aggregated total. If you've been following this series step by step, you'll realize that all this data lives in a Django app that's being deployed on an Elastic Beanstalk environment. If you haven't watched the previous videos on how to set up an Elastic Beanstalk environment with a Django app, please watch the previous videos. Anyway, let's get started. What we're going to be doing here is building a extremely basic UI in SwiftUI. So what we're going to do first is we will create a VStack that will have an alignment of center, and it'll have some content, but I personally do not like writing it like this, so I'm going to write it myself, and I'm going to set the spacing to 0 because I'd rather set the spacing manually in case Apple decides to update their default implementation. Next, I'll add a title text that'll be, "What did you eat today?" Something simple. And as you can see, the preview is updating as I type. If it stops updating after I type, it means there's probably an error, in which case I can fix it right away. Next, I'm going to create a text editor and give it some input text. This will require a binding, so I'm going to create an input text binding, and I'll create it up here. And it's going to be of type string. I'm going to style the text editor. I'll give it a font of body. I'll give it a frame with a max width of infinity and a max height of 150. I also want my text editor to have a rounded look, so I'll give it an overlay. Next, I'll give it some padding, and I'll give it 24 pixels across. And here we have a rounded text editor. Next, we'll create a button so that we can actually tell the backend what we ate today. So I'm going to set the closure for the action to empty because I haven't actually written my function yet. And what I'll do is I'll set the label to some text called submit, and I'll style it with Next, I want to set the button to be disabled whenever there's no input text. Next, I'm going to create a button similar to the one we created above, except this time I want a reset button. So I'm going to create a reset button and style it similar to how I did before, but I don't want any color around it. I want to make sure our reset button is disabled if there is no input text available. Let's test out what we have to make sure our submit button and reset button get enabled whenever we add input text. As you can see, the submit button and reset button react just as expected, and if I delete everything, the button should start to disable. Great. Next, we're going to create an observed object that will hold our view model, and we're going to create a NutritionViewMode with a default initializer. Again, we have not created this model yet, so we'll go into our newly created NutritionViewMode class, and we will create a NutritionViewMode that is of type observable object, and let's give it the observable conformance so that we don't have to write @publish for every single property. We're going to create a variable called foods. Again, we have not created this food struct yet, but we'll create it in a bit. And we'll keep an aggregated sum of every single nutrition fact so we can display in our list. Next, we're going to create a property called isLoading. And what this will do is it'll allow us to tell our view that we're loading, so it can show a loading indicator until we actually receive all of our data. We'll set it to false initially. And to avoid the complaints that we're getting from the fact that we haven't created our foods yet, let's add that now. Here we have our food object, which is of type identifiable. It conforms to identifiable because it has an ID. This will be used for when we iterate over all of our foods from our food model. We're going to create our functions that allow us to respond whenever we tap on submit selected or reset selected. So let's do that now. And these functions are going to run on the main actor. So func submit selected, and we're going to pass it the input text from the view. It's going to be async. The first thing we'll do when we select submit is that we will toggle the isLoading state. And then we'll just await the input text. We could of course do some checking on the input text to make sure there's no incorrectly formatted letters or words, but that's something we can do later on. We haven't created the process text function yet, but we'll do that soon. Next, let's create a reset selected function so that we can reset all of the fields that we created. Next, we're going to create a function called process text. And we'll pass in some input text that we showed earlier, and it's going to be an async function. All the work is going to be done within a task, and we're going to do a do catch block where we will create a URL with a string, and this is going to be the name of our server. If we cannot get the URL, we'll just reset the foods. This shouldn't happen. Next, we will create a URL request with the URL we just created, and we'll set the request's HTTP method to be post.
And then we'll create a JSON body to pass into the URL request.
Then we will set the HTTP body to a serialized version of our JSON body. And we will make our HTTP request. We will check the response data by checking the response data's decoded string. This is just for sanity checks. For us to test the debug print, we need to have our process attached to the simulator process. We can't use the Swift preview to be able to see what we printed out. So what we'll do here is we'll type in what we ate today. Today I ate 4 ounces of chicken breast and 5 slices of wheat bread. Okay, so it says that the resource cannot be loaded because the app transport security policy requires the use of a secure connection. Clearly we don't have a secure connection because we're using HTTP, but we need to have an HTTPS to be able to not get this warning. So what we'll do is we'll override this temporarily since we're testing, and we'll go into our track a demo project, go into our track a demo target, and select capability, and we'll add the app transport security exception just for testing. And so we've created an app transport security exception, and we'll add canyoutrackit.com. And so now we've created an exception. So what we'll do here is we'll run our app again. Today I ate 4 ounces of chicken breast and 3 slices of wheat bread. Great, so it worked. We're able to add the exception domain, and we're able to see our JSON response exactly how we expected. Now that we know what our result looks like, let's actually decode the results. So we'll create a new variable called ingredient result, and we will use a JSON decoder, and we'll decode the ingredient result from the response data. And we haven't created an ingredient result object just yet, so we'll have to create that now. So I have some code that I've already copied and pasted that handle all of this. So we have our ingredient result, which have a result, which is of type ingredient, and we have an ingredient object. And within our ingredient object, we have a measurement unit, we have a coding keys so that we can correctly decode our values, and we have the actual properties which we want to decode. And I've created a property that's computed every single time it's accessed that gets the total calories. All it does is it just takes the fats and multiplies it by 9 because there are 9 calories per gram of fat. And with other calories, because carbohydrates and protein have the same number of calories per gram, I just add them together, multiply it by 4, and then I just add fats and other calories together to get the total calories. And here are some extensions I added to make things more convenient for me to compute. For example, if I have a value between 0 and 1, I want it to have a formatting of 2 decimal places. But if it's greater than 1, then I just want to format it with 0 decimal places. So it just shows like 10 calories or 5 calories. So I only want to add more precision if it's less than 1. And for serving size, I just get the tenths and I format the tenths by getting the truncating remainder divided by 10, and I format it with this 0f to give it no decimal places. And if it has a remainder, then I give it 1 decimal place. And of course with string, I want to be able to convert from string to double. So if I'm able to make a string a double, then I just return the double version of the self. Otherwise I return 0. So with all this said, let's actually build our UI. Next thing we want to do is we want to actually aggregate all of the ingredient data from our ingredient result. So we'll do this all on the main actor. And we'll set is loading to false because we've actually gotten all of our data, every single ingredient in ingredient result. What we'll be doing is we'll take our total fats and we'll just add whatever the total fats on the ingredient is. And then we'll multiply by the ingredient's conversion factor. Now that we've gotten our foods, we want to catch an error in case there is one. And what we'll do is we'll run on the main actor and we'll just do debug print the error. And we'll set is loading to false, and we'll set the foods to an empty list. The next thing we'll add is a ZStack because we'll need to not only show the list, but we need to show a progress view that's on top of the list in case there's loading that needs to be done. So we'll create a list, we'll create a section, and in our section we'll create text, but before we display any text, we're going to check if there are no foods. And if there are foods, we'll say foods. Otherwise, we'll say enter what you ate above to see your daily nutrition. Then we'll set its font. Next, we'll add some list row insets. After this, we will add each of our food items, and we'll iterate over all of our foods. Next, we'll add a spacer. And we'll make it trailing so that all our nutrition facts will be at the right side. And to the right of our fats, carbs, protein, fiber, and calories, we're going to actually show the real values. So after displaying all of our foods, we want to be able to display an aggregate total of everything displayed. So let's verify that we actually have some foods in our food model. And if there are foods, we'll create a section. And instead of fats, we'll do total fats. We'll add some padding. And we'll set its list row insets. We'll set the list style to inset grouped. And if we're loading, we want to be able to show a progress view. Let's input some text into our SwiftUI preview to verify everything is working properly. As you can see, we have eaten 5 ounces of chicken breast, which shows up in the first row with our 5 ounces here and our macronutrients to the right. We have our wheat bread, spinach, extra ground beef, and our totals. And that's it. We were able to integrate a Django app into a Elastic Beanstalk environment, be able to deploy it, map it to a domain that we created through Route 53, and be able to display everything in a SwiftUI preview. If you made it this far into the video, make sure to leave a comment and like if you haven't already, and make sure to subscribe for future content like this. If you have any critiques or comments about the app architecture or how this was done, leave a comment and we can have a discussion back and forth. I'll see you in the next video.